Hello, this is Mr. Win, and this video is about the law of cosines. So the two cases remain from the list conditions from before on how to solve an oblique triangle, SSS and SAS. If you're given three sides or two sides and their included angle, the angle between them, none of the ratios in the law of sines will be complete. We cannot finish any of the fractions. So if we can't do that, we use the law of cosines. It's a straightforward formula where you get a squared equals b squared plus c squared minus 2b times c times cosine of a. It's kind of like the Pythagorean theorem, but you minus 2 times the two things are on the same side times the cosine of whatever letters on the left side. Now, if you solve each of these for cosine A, cosine B, cosine C by just subtracting b squared, subtracting c squared, divided by negative 2bc, you'll actually get things like this. So use either format. This right side is the left formula is rearranged. Anyways, let's try solving this problem. Find the three angles. Here we try to do sine of A over 8 equals sine of B over 19 equals sine of C over 14. None of the fractions are complete, so we cannot do law of sines here. So we're going to do the law of cosines. So the law of cosines, do one of them at a time. Let's find B first. We can fill in A, B, and C. Then we get cos B equals negative 0.4. Can cosine be negative 0.4? Answer is yes. Cosine is negative in quadrants 2 and 3. They found out it is obtuse in quadrant 2, so it's 116, because it has to be between 0 and 180. Once we know one angle, it's better to use the law of sines. So sine of A over A equals sine of B over B. We know A, we know angle B, and we know B. Fill it out, we get this. Sine of A equals 0.37. Arc sine both sides to get A equals 22 degrees. Then do triangle sum to get angle C is 41.2, 41.12. Alright, so by the way, the law of cosines is very long, so you don't do it multiple times in the problem. You could have done it 3 times here and we got all three angles, the same three angles. But after you do it once, you should probably finish with the law of sines. Next, it was smart that we found the largest angle first. Why? That's because if we find out the largest angle is obtuse, the other two angles must be acute. If we found the largest angle is acute, that means the other two angles must also be acute. If we found the smallest angle or we found a different angle that wasn't largest, we would not know if our triangle overall was obtuse or acute or right. So try to find the biggest angle first. Alright, here you go. Find the remaining angle inside. So we can't do any of our law of sines. We can't do sine of C over 10 equals sine of B over 15 or sine of 115 over A. So we do law of cosines again. Just use the normal formula. They chose to solve for A. So they filled everything out, calculated it. They got A squared is about this. Square both sides, get 21.26. Again, you want to use a calculator for law of sines and cosines. Once you have that, we can use our law of sines to find the other thing. So they found sine of B is 0.63. You want to find B by arc sining that. So sine of B, so B equals arc sine of 0.63. That's a calculator. You get 39.75 degrees. Then you do triangle sum, add up the two angles, subtract 180 to get the remaining angle of a triangle. Alright, here's a word problem. Pitcher's mound on top is 43 feet from home plate, and each base is 60. The pitcher's mound is not halfway between home plate and second base. How far is it? So we are going to do the law of sines. So here's the formula. We're trying to find h. So h squared equals f squared plus p squared minus 2 times f times p times cosine of this angle 45. That angle is 45 degrees, so that's half of 90. They fill it in, they calculate it, 1800, so h squared is 1800. You're going to square both sides to get 42.43 feet. Alright, here's the ship travels 60 miles due east, so starting at point A, they go east 60 miles, then they start heading northward 80 miles with no angle. At the very end, that's 139 miles from its starting point. Find the bearing from point B to point C. So first, let's talk about bearing. Alright, bearing, when we talk about bearings, we start at north, or true north, and go clockwise. So this redoes our unit circle kind of. So we start at 0 degrees here, then here's 90, here's 180, 270, 360. Alright, so if I talk about north 35 degrees east, that means we're heading, so think of this like a origin here. We're going northwards, then we turn 35 east. So this top angle is 35. This bottom angle would be 55. If I said north 40 degrees west, we're going northward and turning 40 degrees to the left. So this is the top angle right here. If I say south 20 degrees east, that means we're heading the south direction, but we turn 20 degrees, so it's the bottom angle here, not this 70-degree reference angle. And the other one, south 55 degrees west, means we're heading southwards, we're going down, but we turned left 55. So make sure you put the angle in the correct spot. Alright, so anyways, in this problem we know none of the angles, we know all three sides, you do the law of cosines to get b. Cosine b is a negative 0.9, that's possible in quadrant 2 and 3, but we're in a triangle, so between 0 and 8, so we're in quadrant 2. We get our cosine of that, it's 166.15. So now that we know angle B is 166, so all this is 166, we need to know from true north, from here, how much they turn. This ship was going this much. Alright, so this is the 166 minus this 9 that we don't need. So that'll give us this bearing right here. So that's why this is north 76.15 degrees east. Alright, anything else? Areas. Alright, we have Heron's area formula. He created this formula to solve for the area of a triangle given all three side lengths and no angles. So area equals square root of s times s minus a times s minus b times s minus c, where a, b, and c are the sides, and s is half of the perimeter. So a plus b plus c all over 2. But once you know this formula, you have three area formulas. You have your standard area equals 1/2 base times height. You have your oblique triangle where you can do 1/2 two sides times the sine of the third side. And I have Heron's formula where you don't need any angles, just three sides. So here's just find the area of a triangle that has the side lengths 43, 53, and 72. I can't use my first one. I can't use the second because I don't have no angles. The first one, I don't know the height or the base. So we're going to use Heron's formula. We can find S, add all three sides, divide by 2, get 84. Plug into the formula. Every S is 84. A is going to be 43. B is going to be 53. C is 72. They get this, comes that number. That's the answer. Alright, that's it for the video. Hope you enjoyed it. Make sure to ask any questions. Thanks for watching. Bye.